Guys, my voice is audible to you and the screen is visible to you. Tell me.
Yes, sir.
Okay. Okay. Till now we have discussed this one yesterday. Okay, this one also we have yesterday discussed. That is cloud versus grid. Okay, here there is no only negligible difference is there with the cloud to grid. Okay, grid is a static thing. Coming to cloud is a dynamic thing or elastic in nature. Okay. Coming to the cloud, whenever you want to increase the resources, we can increase those resources. Like for suppose for particular doing one project, I need high processor capabilities or high end operating system. Okay, at that time just one mail to the cloud is enough, one request to the cloud. Okay, after seeing that cloud, okay, they will increase the processing capabilities or operating system to you. Okay, it's in dynamic in nature. Okay, with a fraction of seconds we can increase that one. But if you went for the cloud, it means it's elastic in nature. What are the services that are there in the grid? We have to use it, that's it. Okay, we cannot use beyond that one. Okay, that is there in the grid. Now coming to the cloud, it uses virtualization, guys. Okay, whenever the cloud is there means there is a virtualization is there. That is why, okay, particularly one lesson is there for the virtualization in the this cloud computing. Clear? Okay. And the second topic related to the softwares, one is related to distributed and cloud computing. The second part is first one is service oriented architecture. The second one is trend towards the distributed system. ఓకే, ఎలా ఉంటుంది డిస్ట్రిబ్యూటెడ్ సిస్టమ్స్లో సాఫ్ట్వేర్ పార్ట్ ప్రకారం చూసుకుంటే కనుక నార్మల్గా వచ్చేపాటికి ఇక్కడ అన్నీ కూడా ఇన్ డిస్ట్రిబ్యూటెడ్ సిస్టమ్స్ దే విల్ హ్యావ్ ద ఇండిపెండెంట్ ఆపరేటింగ్ సిస్టమ్స్. Each, for suppose in distributed system, you know, different locations, different systems will be there, and each and every system will have the individual independent operating system to get the better performance and fast communication. Okay, what is the proposed one in the distributed systems is distributed operating system. Okay, some OS will be in there in the one system, some part of the OS will be there in the other system, some other part of the OS will be there in the other system. Those systems will be in different locations, but they combinedly merge and manage the resources effectively. If it is happens, that is the one. Okay, we are expecting those things in the future also. Understand, guys? Okay, clear? Till now we have discussed yesterday. Okay, this is the fourth subtopic. Okay, let us go for the newer one. That is the fifth subtopic, guys. Let us start the discussion related to this one. Okay, here the performance, security, and energy efficiency. How we will measure this, all these things, performance, how we will measure in the distributed or cloud computing systems, how the security will be measured in the distributed and cloud computing system, how we have to save the energy in the distributed and cloud computing systems, we have to see it. How we have to measure the performance related to the cloud and distributed systems, and how we can provide the security in the distributed and cloud computing systems, and energy and efficiency we have to discuss in the next coming topics. Okay, here mainly we have to discuss the five main things. That is, the first one is performance matrix and scalability. Performance matrix and scalability. Performance, how we can measure the performance. Normally in a system, how we can measure the performance, guys? For suppose if you give the any project or any program, if that one is executing very fastly, that means the performance is good for that system. Normally we will think like that, right? Okay, you need no hang-ups. Okay, no restarts. Okay, if all this happens means the system is performance wise okay, we can say that one. And moreover that guys, we will measure how it is scalable. Okay, for suppose, okay, if you want to add the more resources, or if you upgrade the operating system or application, okay, or upgrade the hardware parts of the systems, okay, how these things will be happen in the distributed systems and clouds also, we will discuss in the first one, that is performance matrix and scalability and analysis. Performance means how far, okay, how fast it is executing, number of instructions per second. We calculate that one as a metric here for measuring the performance in the distributed and cloud computing system. How you can, the scale means, scalability means how far it able to increase or reduce the resources are related to hardware wise and software wise and networking wise. All these things also we will discuss in the performance matrix and scalability and analysis. First one. The next one is fault tolerance. Okay. Why this one is very important here, guys? Fault tolerance. For suppose, guys, why I am saying this one, how why this fault tolerance is so much important related to the cloud computing or distributed, guys. For suppose we are doing the project, guys, for 5 years. Okay, at the end of the 5 year I have to submit that project, very big project. For that cost for that project is for suppose 100 crores. Okay, we are developing the project and 4 years 4 months we have done a hard work to complete the project. Okay, the maximum 95% complete project is completed for suppose. Okay, one fine day one natural calamity has happened. Okay, the content inside the server is all the thing is vanished, means the 4.5 years work is vanished, and the four and a half manpower is vanished, and energy is also wasted, and the money is wasted, and time is also wasted. Okay, if you are not protecting the information, we cannot, if we are not protecting the information that is there in the server, that means we lost everything. Okay, 4.5 years of the content and money, everything will be lost. Okay, at that time also, how the system is available, that one we have to discuss in the second one. Like placing the duplicate things, like placing the duplicate servers in different locations. Okay, for suppose one server is lost, that will connect it to the another server there in the other location, then no information will be lost, the project will be as it is working. That we call them as system availability. Every time the system should be available. Okay, how that will be achieved in the distributed systems, how that will be achieved in the cloud is also we will discuss. Okay, in the second one, fault tolerance. Anything happens, how the system is available for working, that one is, we call them as a system availability. Right, guys? The third one is it's related to threats from outside, network threats, malwares, attacks, hackings, data completeness, data integrity, how we are maintaining the accuracy and completeness in the data, that we will discuss in the network threat and data integrity, network threats and data integrity part. Okay, how we have to handle these malwares, all these things we will discuss in the network threats and data integrity, guys. Okay, the next one is uh, how it is saving the energy, how far it is saving the energy, how effective related to the energy. Okay, that we will discuss in the fourth one, that is energy efficiency in distributed computing. These four points you write it down, guys. I will give 1 minute. Okay, let us start the discussion related to the first one, that is performance matrix and scalability analysis. Performance matrix, how we will measure the performances in distributed systems, and how the scalability we have to do in the distributed system. Let us discuss in the first one, that is performance matrix and scalability. Okay, in this performance matrix and scalability, we will discuss different performance metrics, how we will measure the performance of a system. Okay, and how we can increase the resources related to the hardware, software, and networking. Those things will be discussed in the second one, that is scalability. Scalability means increasing or reducing the resources. How we will done that one in the distributed cloud computing we will discuss. Okay, let us start the discussion related to the performance matrix first, then we will go for the dimension of scalability. Okay guys, for distributed systems the performance is measured very different factors are there. In that, one is a system throughput that will be measured with the help of MIPS. Okay, million instructions per second. Okay, how many million number of instructions are executed per second. If it is the very high, you can say that the system is performance wise okay. Likewise, T flips, that is also one of these performance metrics wise. T50 means tera floating point operations per second. Okay, how many number of floating point operations are executed per second, that is also one of the measure for performance. If it is high means number of operations will be executed more, that we can say that the system wise performance wise very good. Likewise, transactions per second, the number of transactions also one of the measure. All these are comes under system throughput. Okay, for suppose I will give a real-time example guys. 3 persons are there. Okay, I have given 100 number of works for the each and every person, the same work for the 3 persons also. One person is done in 1 minute, for suppose 50 tasks he has completed. Second person 25 tasks is completed. Third person 75 tasks is completed in within 1 minute. Who is performance wise more? The third person will have the high. Likewise, here also the number of that the system performance can be measured with the help of number of instructions executed per second. For normally for persons, number of tasks work. Okay, here 25, 50 and 75. Who is the highest one? 75. He is performance wise is good. Likewise, here also the number of instructions executed by all these things. MIPS means million instructions executed per second. Here the next one is T flops. That means there are floating point operations executed per second. A transaction executed per second. Here the second wise we will take in within 1 second how many instructions are executed. That we call them as a throughput. If the throughput is high means we can say that the performance wise very good. This is one of the measure related to the distributed systems. Okay. Yeah, some other measures also there guys. That first one is job response time. The second one is job response time. For suppose job response normally for person, job response time means after giving the work, after completing the work, he has to give the response to the person what previously ఎవరైతే ఇచ్చారో వాళ్ళకి ఆ రెస్పాన్స్ అనేది ఇవ్వాలి. దీని మొత్తాన్ని ఏమంటాం? we call them as job response time. Likewise in the system also, okay, after giving any task, okay, after that system what it will do is it will execute that work, okay, one by one instruction after the other, okay, and it will take all the input needed for that job, complete that job, okay, and give the result back. All this time we call them as a response time. Okay, రెస్పాన్స్ టైం ఎప్పుడు కూడా రెస్పాన్స్ టైం అనేది ఎప్పుడు కూడా తక్కువ ఉండాలి. అంటే జాబ్ ఇచ్చిన తర్వాత కంప్లీట్ చేసిన తర్వాత రిజల్ట్ బ్యాక్ ఇవ్వడానికి ఉండే టైంని రెస్పాన్స్ టైం అంటాం. ఇది ఎప్పుడు కూడా తక్కువ ఉండాలి. ఓకే, ద నెక్స్ట్ వన్ ఈజ్ నెట్వర్క్ లేటెన్సీ గైస్. నెట్వర్క్ లేటెన్సీ ఈజ్ నథింగ్ బట్ ద టైం టేకెన్ ఫర్ ఎ డేటా టు సెండ్ ఫ్రమ్ ద సోర్స్ టు డెస్టినేషన్. ఓకే, మనం డేటాని ఒక సిస్టమ్ నుంచి ఇంకో సిస్టమ్ వరకు, సోర్స్ నుంచి డెస్టినేషన్. ఓకే, ఫర్ ట్రాన్స్ఫరింగ్ ద టైమ్ గ్యాప్ బిట్వీన్ ద ఆఫ్టర్ సెండింగ్ ఫ్రమ్ ద సోర్స్ టు ఆఫ్టర్ బిఫోర్ రీచింగ్ ద డెస్టినేషన్. దిస్ టైమ్ వి కాల్ దెమ్ యాజ్ ఎ రెస్పాన్స్ టైం. ఓకే, అది ఎప్పుడు కూడా తక్కువ ఉండాలి, ఇది కూడా లో లేటెన్సీ ఉండాలి ఎప్పుడు కూడా. ఓకే, దిస్ వి కాల్ దెమ్ యాజ్ ఎ నెట్వర్క్ లేటెన్సీ గైస్. ద టైమ్ టేకెన్ to send the data from the source to the destination, it should be low. ఫర్ ఎగ్జాంపుల్ మనం ఇక్కడ డేటాను సెండ్ చేసి డెస్టినేషన్ రీచ్ అవడానికి 2 days పట్టింది అనుకో, ఇంకెప్పుడు రిసీవ్ చేసుకుంటుంది డెస్టినేషన్, ఎప్పుడు కంప్లీట్ చేస్తుంది. అందుకని ఎప్పుడు కూడా ద లేటెన్సీ, నెట్వర్క్ లేటెన్సీ షుడ్ బి వెరీ లెస్. ద జాబ్ రెస్పాన్స్ టైం కూడా చాలా తక్కువ, ఫాస్ట్గా అయిపోవాలి కంప్లీట్గా. Okay, these two are also other measures in addition to the system throughput. Okay, other one is high bandwidth. Also, they have to maintain in the network. Fast ga data transfer cheyali. That is, we call them as a bandwidth. Okay, more or less latency అనే కూడా అంతే అలాగే ఉంటుంది. All these are the measures. System throughput means instructions executed per second, number of instructions executed per second. Okay, if for suppose three systems are there, in the three systems one system is executing the more number of instructions, means performance wise that one is the high. Okay, next, job response time. Okay, giving to completion and response from that, uh, we call that one as a జాబ్ రెస్పాన్స్ టైం. మనం వర్క్ ఇచ్చిన తర్వాత వర్క్ కాల్ తీసుకొని కంప్లీట్ చేసి రిజల్ట్ బ్యాక్ ఇవ్వడానికి మధ్యలో ఉన్న టైం మొత్తాన్ని ఏమంటామండి, రెస్పాన్స్ టైం. దట్ షుడ్ బి లెస్. నెట్వర్క్ లాటెన్సీ మీన్స్ సెండింగ్ ద డేటా, టైం టేకెన్ ఫ్రమ్ ద to send the data from the source to the destination. That we call them as a network latency. That should be very less. Okay, that is also one of the performance measure. Okay. Likewise, high bandwidth, ఎక్కువ డేటాని సెండ్ చేయగలిగేట్టు ఉండాలి. Right? That is also one of the measure for the performance metrics related to distributed systems and flow. Okay, this is the first one. Previous one is performance metrics is the first one. Okay, next one is dimensional scalability. Okay, scalability means adding the resources. That resource may be hardware or software resource or network resource, anything. Okay, depending upon our need. Suppose at one point of time the operating system is not enough to do the desired work. Okay, some updated operating system is needed. First of all, ఆ సిస్టమ్కి ఆ ఆపరేటింగ్ సిస్టమ్ అనేది ఇన్స్టాల్ అయ్యే ఛాన్స్ ఉంటేనే కదా మనం ఇన్స్టాల్ చేసుకోగలం. దట్ ఈస్ ఆల్సో వన్ మెజర్. Likewise, any for do one project we need the updated resources. Okay, updated hardware. ఆ హార్డ్వేర్ ని ముందర ఈ సిస్టమ్ కి యాడ్ చేసుకునే క్యాపబిలిటీ ఉండాలి. లేకపోతే మనం యాడ్ చేసిన సరే అది వేస్ట్ అవుతుంది అనమాట. దట్ ఈస్ ఆల్సో వన్ ఆఫ్ ది metrics related to the scalability. Okay, in that different scalability are there. First one is size scalability, software scalability, and application scalability, technology scalability. Okay, how we will increase the sizes? System size means increasing the resources inside the system. Software scalability, upgrading the softwares or installing the new softwares or any patchwork related to the software, that we call them as software scalability. Application scalability and technology scalability. Technology scalability means adding the new networks for completing one particular work. All these are things related to the scalability. Okay, how far we are adding the resources, that will comes under scalability here. మనం సిస్టమ్ యొక్క కాన్ఫిగరేషన్ కానీ రిసోర్సెస్ కానీ ఏ విధంగా యాడ్ చేసుకోవచ్చు అనేది స్కాలబిలిటీ ఉంటుంది. దాంట్లో వచ్చేప్పటికి డిఫరెంట్ టైప్స్ వచ్చేప్పటికి సైజ్ స్కాలబిలిటీ, సాఫ్ట్వేర్ స్కాలబిలిటీ, అప్లికేషన్ స్కాలబిలిటీ అండ్ టెక్నాలజీ స్కాలబిలిటీ. We will discuss these all the things. Okay, coming to the first one, size scalability, increasing the machine size. Nothing but adding the different hardware parts like processor, that may be, or cache memory, or RAM, or storage, or IO channels. All these are comes under size scalability. Increasing the size of the system means increasing the capacity inside the system, like adding the different processors, cache memory, storage, and IO devices. All these will comes under this size scalability. Here one point we have to remember, guys. For suppose for particularly for my system, I can increase the RAM size up to 8 GB. Okay, another system is there. Okay, in our మన IT lab లోనే చూసుకుంటే కనుక we can increase the RAM size up to the 16 GB. Okay, Here for my system I can add maximum only 8 GB RAM only to particular my system. For my IT lab computer, okay, we can add up to 16 GB. That is the limitation. Likewise, we can add different processors also in the parallel. If you take the example, guys, IBM S2, okay, we can scale up, means increase the number of processors in that system to 512. మన ఆ సిస్టమ్కి వచ్చేప్పటికి ప్యారలల్గా 512 ప్రాసెసర్ని యాడ్ చేసుకోవచ్చు. బట్ దట్ ఈస్ ఇన్ 1997 guys. But in 2008 guys, particular system IBM Bluegen L, this system we can scale up the processors to 65,000. We can add the parallel, we can add the processors up to 65,000. It depends upon the system guys. Number of processors adding, that will be depends upon the system. Okay, that is the point. Okay, that is also depend upon the system. Size capabilities means adding a different resources like hardware resources, processors, memory, storage, IO devices. Here adding also some restrictions are there. It depends upon the system to system. Particularly if you take the IBM S2, we can add only 512 processors. That is a older version. Okay, the newer version IBM Bluegen, for this one we can add up to 65,000 guys processors. You can increase that one. Okay, that is the related to size scalability. Next one is software scalability guys. Okay, how we can scale up or scale down related to the software. Okay, that scaling is related to the upgrading of operating system for doing particular job work in a particular operating system. Okay, for suppose if I take my system, okay, I can install Windows 10, but the older systems we cannot install the i10 Windows 10 operating system. That is a limitation. Okay, this is the software scalability. We have to, this is one of the metrics. Okay, how we can increase the operating systems or compilers. Okay, upgradation అవుతుందా అవదా అది కూడా మనం చెక్ చేసుకోవాల్సి ఉంటుంది. సాఫ్ట్వేర్ స్కాలబిలిటీ మీన్స్ ఆపరేటింగ్ సిస్టమ్ ఆర్ కంపైలర్ ఆర్ నో అప్లికేషన్ ఆర్ upgrading the already existing software like patchwork related things. All the things will comes under software scalability. ఓకే, నువ్వు అప్లికేషన్ ఇన్స్టాల్ చేయగలగా లేదా మన సిస్టంలో వచ్చేప్పటికి కొన్ని వచ్చేప్పటికి ఫర్ ఎగ్జాంపుల్ ఆండ్రాయిడ్ స్టూడియో ఉంది, మరి మీరు యూజ్ చేసుకున్నారు, ఒక దాని గురించి వర్క్ షాప్ జరిగింది కదా. ఓకే, ఫర్ దట్ వీ నీడ్ మినిమం 8 GB ఆఫ్ ర్యామ్. ఓకే, వితౌట్ ద 8 GB ఆఫ్ ర్యామ్ దట్ సిస్టమ్ విల్ బి స్టక్. That system have the first of all 8 GB of RAM to install that Android Studio Mini. Okay, otherwise the system will be stuck or it will shut down. Okay, that is one of the limitation. Okay guys, one thing is for suppose I am using one software. Okay, the upgraded version will be for suppose that accepts only 8 GB RAM. For suppose I am using only 4 GB of RAM in my system, the upgradation won't work for the particularly for my system. Why? Because the upgradation of software, okay, for that requires 8 GB of RAM. Okay, but the previous version is only for 4 GB. Okay, here my system is only using 4 GB of RAM. To install that upgradation, I have the 8 GB RAM in my system, then only the updation will be work. This is also one of the limitations related to scalability. Okay, right. The next one is application scalability guys. Application scalability, for suppose we are doing one project guys, for the data set size is something. Okay, the data set size is also increasing. Previously for the particularly small amount of data set, my system is working fine. Okay, the data set means it increases day by day, right? Okay, after 1 year of work the data set size is increased so far. My system is unable to process that much amount of data. What I have to do is I have to increase my system capabilities. Okay, in parallel with the workload that is increased, that we call them as application scalability. Okay. uh, రిలేటెడ్ టు ద డేటా size అయితే ఏ విధంగా అయితే ఇంక్రీజ్ అవుతుందో అదే విధంగా వీ హ్యావ్ టు ఇంక్రీజ్ ద సైజ్ ఆఫ్ ద సిస్టమ్ ఆల్సో. ఓకే, రైట్, దట్ ఈస్ ఆల్సో వీ విల్ డిస్కస్ హియర్. అప్లికేషన్ స్కేలబిలిటీ, అప్లికేషన్ ఏ విధంగా అయితే ఇంక్రీజ్ స్కేల్ అవుతుందో అదే విధంగా మన సిస్టమ్ కూడా దానికి ప్యారలల్ గా అదే విధంగా స్కేల్ అవుతూ ఉండాలన్నమాట. దట్ ఈస్ వీ కాల్ దెమ్ యాజ్ అప్లికేషన్ స్కేలబిలిటీ. ఓకే, ద లాస్ట్ వన్ ఈస్ టెక్నాలజీ స్కేలబిలిటీ. టెక్నాలజీస్, ఇప్పుడు మనం నోవేడేస్ కొత్త కొత్త టెక్నాలజీస్ వస్తూ ఉంటాయి కదా, ఆ టెక్నాలజీస్ కూడా మన డిస్ట్రిబ్యూటెడ్ సిస్టమ్ లైక్ న్యూ నెట్వర్క్ టెక్నాలజీ అనేది వచ్చింది, దాన్ని అడాప్ట్ చేసుకుంటాకి మనం కొత్త మన సిస్టంలో కూడా ఆ నెట్వర్క్ సంబంధించిన టెక్నాలజీస్ని మనం ప్లేస్ చేసుకుంటే కనుక దాని ద్వారా వచ్చేపాటికి మన సిస్టమ్ వచ్చేపాటికి బయట సైడ్ ఉన్న వరల్డ్ తోటి ప్యారలల్ గా వర్క్ అనేది ముందుకెళ్తూ ఉంటుంది. That we call them as technology scalability, adapting to the changes in the different things related to technology, like networking, one example, or components, new components are coming. That one also adapting, and we have to installing. That we call them as technology scalability. Right, guys? Okay, ma'am. Okay, yeah, you will do. Krishna, very much.